Well, basically, to start, first of all, I have to thank all the individuals supporting this hands-on activity coming from several institutions. And essentially, what we are going to do is trying to map units and figure out what's on the surface. Monica introduced already that we are in between geology and geomorphology when it comes to mapping. And what we're going to do in this particular case is to try and map a single basin. So the sedimentary basin that, or the basin without mentioning sedimentary processes yet, that we're going to map, it's not so different from the one that you map on the moon. And more or less, this is a kind of an incremental way to look at processes that are acting on a surface. And the reason is that, of course, on Mars, as explained by both Lucia and Monica, there is a variety of processes on top of the ones that are already present on other bodies such as Mercury and the moon. Now, that's a general statement that ground truth is important. One can try to overcome the limit of not going to the field, having samples, measuring the composition of rocks, and actually measuring ages radiometrically, having fossils with multiple data. And that's more or less what we have to do in our daily life. But of course, that's an example from, so to say, an analog mapping exercise that was done a few years ago on Earth, but with a planetary mapping approach. Different people, so the top map is the real geological map, and the 4 below are 4 different mappers. And you see, they're all different, but many things actually have in common. And obviously, certain things are relatively easy to understand and map, certain others less, either because the data are limited, or because even with very high resolution data, without field data or sample return, it's just impossible to discriminate between certain units or materials. So that's what we're going to do on Mars. And well, why do we do it? Of course, we do it to try and figure out a sequence, a story, so to say, a geological narrative out of the landform and the outcrops that in this particular case is focusing not on a place like Eberswalde or G0, where there is quite some exhumation, so material have been eroded quite a lot, but in a basin when such erosion is a bit less. This has plus and minuses. Of course, the plus is that you can see better the landform. The minuses is that you have less outcrops and you can access less lithologies and architecture of the deposits that you actually observe. We are building on the activities both technically and scientifically, because technically we are using the very same approach. We are using essentially the very same tools, and the data, they are really similar. On top of impact and volcanic processes, which again are impact ones are producing our sedimentary basins, there will be both the positional and erosional processes that you just heard from Monica. The structure is as such. We go briefly to a description. We go through the characteristics of the area, but then when we split at 11:30 or so into breakout rooms, each instructor will go with the GIS data through the area, and we can start getting moving. We will also, we'll have a break and we will continue into breakout rooms. I would suggest, to avoid losing time, to actually keep the connection on if possible, unless you're using your own mobile data rate, to keep the connection on, just mute and close the video, so that actually after lunch we can start without having to restart again the breakout rooms. In case of problems, we will try to solve them. Then important, we would like to stop at 4:30 CET PM sharp, so that we can get together and share a bit of results and have a kind of at least 1 minute glimpse out of each group. Then we will introduce some other issues later on at the end of this debriefing. These are the instructors. You will meet each of them personally in the breakout rooms, but they're all available. You can find them both on the chat. Otherwise, we can iterate on the forum for those that you may want to do this asynchronously. And in fact, this first part will be recorded. The individual groups can be recorded if everyone agrees, and it would be nice that at least one is available for those that are, so to say, participating asynchronously. Some reference documentation, some is internal, so to say, self-contained in the school, the map PO2, the symbology PO2, and some others, if we manage to use them later on. I'll show you in a moment around the use of layout maps. There are some limits, but we will discuss it. The tools, of course, or at least the data we are going to use, are essentially a QGIS project like you did on Mercury and on the Moon. And in case of any technical problem, we don't want to be stopped by so to say, technology. There is also, I mean, a map, and we can use other less high-tech tools. But it would be nice to actually build upon what we did so far and work on a GIS. One point of information, of course, we had to choose a reference system. In this case, partly because I was lazy, I took the HRC data, I'll tell you in a moment, and I matched everything to this. We have a sinusoidal projection on Mars, of course, not on Earth, centered on a certain longitude, which happens to be the integer longitude passing nearby this crater, this basin that you will see, and with a certain reference body. The mapping scale, Monica was mentioning that. Of course, it depends on two things. First of all, and the limiting factor is the resolution of your data, and which is also our limiting factor. And the second one is how much time you have. Obviously, if you have a lot of time, you may want to go more detailed. But since we have 2 or 3 hours, we may want to be to make a trade-off. So just to show you, these are different views of the same area at the scale, at least on my laptop, at 100K and 50K. So you see something in between these two would be desirable, to have a kind of a compromise between detail and speed of the process. These are the steps that I just want to go very briefly. I mean, we are not so formal. I just try to kind of formalize them a bit to make it easier, because some of them, it's already started mostly, at least the overview is going to start soon. We will load data, but it's already preloaded for you. We will then look at the contacts, and you did it on the Moon, you did it on Mercury. Looking at for contacts is the key to define units. Even when you go on Earth and you survey, when you go with the car, you walk, the thing that you're always trained to look for are contacts, because then you can try to trace them and you can isolate the units. Then we'll try, of course, to give some names to them. We'll try to embed them into a stratigraphy. The relative age, of course, is stratigraphic in nature, so we're not going to measure in this particular practical ages. And then we try to close the polygons and more or less make our little map. We will try to symbolize this map and interpret somehow what we find. Finally, as I said, as you did on the Moon and Mercury, it would be very nice, actually it will be required if you want to have a certificate, to share your results into a kind of a screenshot that you can upload. And this is relatively easy. You can either put it on the cloud or there is a web page dedicated to that. The only thing important, try to make the file names self-explaining and clear. So use your first name and last name. Just some trick, this probably, I don't have to say it now, but you can use, you will have access to these slides and you can use them when you're doing your practical, but scale bars are tricky on GIS, on this version of QGIS, so don't trust them too much. There are some caveats, we can talk in the groups about that. That's actually how the crater looks like. It's about 70 kilometers in size. Here you see it in 2D, here you see it in 3D.
We do not see the crater yet. We are stuck on your hands-on steps.
Ah, sorry. I think I may want to stop sharing and reshare. Can you see it now?
Not yet.
No.
No.
Another attempt. Can you see it?
No, still.
Funny, because I'm sharing.
Well, we're stuck on Angelo Rossi has started screen sharing, but we don't see the screen.
Funny.
Same here.
So let's start do that.
Angelo, I can share it for you, and you can try.
Yes,
to
that actually would be great, Rick, if you have, because it may be
Yes.
something related to my connection. If you share it and you go to slide 20, please.
Slide 20, yes.
21, actually.
Okay, give me a second.
Thank you so much, and thank you everyone for the patience with technology that failed us today with Zoom and not the PGIS yet.
Okay, almost there. Okay, you should see.
Excellent, Rick. Thanks, I see it. Okay, well, this is just a kind of a global view of the basin. So you see it's a close impact basin, and it shows already some more characteristics. There is another crater inside, and but other than that, it doesn't look so much different from the moon. If you go to the next one, Rick, thanks. Where it's located actually not too far from the dichotomy that was mentioned by Lucia, and in an area where in fact there is quite a lot of kind of candidate paleolakes with some sort of record of fluvial-lacustrine activity. So it's called the Xante Terra area, and it's a bit north of Valles Marineris, a bit south of the Northern Plains. If you go to the next one, you see there is no legend yet here. But in the global map, we are located here. So again, we are not so far from Valles Marineris and Tarsis. And if we try to zoom in regionally, you will see in the next one that actually we are in an area with mostly Noachian and Hesperian units. And the great thing that you see on the left, it's actually the mosaic that we will be using as a kind of a prime data set for our mapping. So we are talking of such an area. If you go to the next one, Ricardo, just to show what we are talking about, with 70 kilometers, we are talking of an impact crater that is a complex one. So we expected this size to have a central peak. We see already something that looks like that. If you go to the next one, Ricardo. Thanks. Essentially, the transition on Mars, it's more or less around this kind of 20-ish kilometer. And sorry, about a bit less than that. So we are well above the threshold. And in fact, we do expect to have a central peak. Now, if we go to the next one, you will see an example of a similarly sized crater. This is Tycho crater, I think. And essentially here in a crater that is pristine and doesn't have any additional processes on top of the impact ones, we expect to have some impact melt, some Brexia, but that's about it. If instead we move to the next one, you see that here there is a bit more complication. I will get back to it in a moment at the end of these few minutes, but essentially here you see that imagine like you have a cake and you cut it. You cut a quarter of a cake. The left part of this profile is one side of the cake cut, and the right part is the other side. So there is some kind of filling of extra cream on this cake, and this extra cream is what we are going to concentrate on. If you move to the next one, I will just go very briefly skimming through, because you will see it in each group in a few minutes, the different units that are cropping out. The next one, please. And even the next one. That's a zoom in of most of the basin. We have, of course, some rim units and ejecta. The distinction between the two is a bit tricky, so they could be put together, or some distinction could be attempted. The next one, please. The inner rim, of course, has the district blocks that were already displayed by Matteo and also by Monica, so they are still part of the bedrock. And then there are also some units that are filling, or at least they're mantling these inner rim portions of the crater. If you move on to the next one, you see that there is a central peak. And if you compare it to the moon, you will see that the central peak, it's smoother, it's less well-defined, and probably this has something to do with the erosional history of the basin. If you move on to the next one, you do have a floor that can be more or less subdivided into subunits, but essentially it's a relatively fat one. And apart from this kind of flat floor, locally, you do see some deposits that are covering it. And these deposits, if you go to the next one, please, they're not everywhere. They're just patches. Now, why a patch is there? It's something that can be discussed and can be interpreted, because patches can be a remnant of something that was everywhere, or can be just something that was locally there. And then, of course, there's some more prominent deposits that are on the northeast part of the crater, the fan shade deposits that, of course, have a feeding channel that you can see in the next one. And obviously, you have many, many small craters, but some of them are large enough that probably at the scale of mapping, 1 to 100K, 1 to 100 to 75K, can be mapped if you go to the next one. Then if you jump one slide or two, you will see that you can also map different kind of linear features. Of course, you can map the channels. You can find something that may be a fault or is likely to be a fault, particularly on the rim. And you can have ridges or other linear features that, again, Monica was mentioning interpretations versus objective mapping. Calling them dike can be too much interpretative, but you can try and also provide your interpretation, hopefully trying to separate it from data. Now, if we go just quickly to the next one and the one afterwards, you see that from the geological context point of view, we are talking of something which has some kind of extra layer of cake. But if we just move to the next one, we can see, again, using a kind of a Minecraft approach, so a very, very simplified, very rough approach, how the different units could be correlated in terms of a stratigraphic relationship, lateral relationship, whether it's heteropy or some other type of contact, for example, tectonic contact, in space, and if you go to the next, in time. So this is, by all means, doesn't want to be a kind of a suggestion of what you should map in terms of unit names, but it's a possible way. We will leave it there for you to discuss with the instructor and the group participants, but this could be one way to map these units. And also here, of course, there is some interpretation, but not too much, a way to actually interpret them. And if you go to the next one, please, Ricardo. There are different things that you may want to discuss when you will start to discuss when you start looking at the contacts, whether they're sharp, they are not, they are clear, they're unclear, whether there is mantling or exhumation of the units. Probably not too much exhumation, but still at least less than what you're seeing with the Bresvalden. And of course, you will see in a moment that the data we are using are relatively rich. There is quite a lot. And this data can help you at least tentatively discriminating the unit types. Now, very quickly to the next one or two slides. These are the data sources. You will have access to the PDF, so you won't have a problem in locating the sources. If you go to the next one, please, there are some references that can be, it will be valuable to use in case, or to refer to if you want to look more into the experiment data. And if you really are curious, the project itself was done with the next one using, again, public data, and information is provided. Is not very different from what Jack was showing on Mercury, and essentially is using open source tools that are available to anyone. The very last slide before we try to move on and split into groups, and this will take a few minutes, so I want to save a bit of time here. There are some references that I suggest you are not looking at now, but to follow up, it will be good to read. Of course, there are many more, but these are a bit more focused into cartography and mapping of sedimentary deposits, and in this case of lacustrine environments. Some of them were quoted already by Monica, but by all means, you don't need to look at them and to work on them immediately, because again, the exercise is try to get into a new area and use the tools and the knowledge that you got so far and the geological context to try and map out things. Of course, when you read papers and you read more about the geology of the area, your interpretation will clearly improve.